I would like to concentrate on is it's covered a little bit in the book, and that is the economic uses of macroalgae. But I want to talk more, probably a little bit more about specific types of compounds that are actually extracted from macroalgae and the types of the uses that we can find for these compounds. So I'd like to start out just by giving you an idea of the economic value of macroalgae production. At least in the United States, and I don't have figures for worldwide, but for the end products that are produced that contain materials that are derived from algae, the market is about $5.5 to $5.6 billion a year for seaweed-derived products. There are something on the order of about 8 million tons, wet tons, of seaweed that are harvested annually. That would be a worldwide figure. And there are about 35 countries that are actually involved in the harvesting and production of these materials, including the United States. And if you go out to California, for instance, where there are giant kelp forests in the ocean, there are actually boats that are specifically designed to go through these kelp forests and actually harvest the material, and they can hold many hundreds of tons of material. Can actually be held by some of the larger vessels. That they can actually take this. These vessels will actually cut the tops off of the algae, which then continue to grow, so that they're constantly replenishing whatever they take out of the kelp forest. But from all that material that is taken out of the ocean, we really want to talk about what kinds of products are being produced from the algae. So the primary products that are being produced are things like agar, which of course is used for, has a variety of uses, but what we tend to use it most for in the lab is to grow microorganisms. They could be bacteria, they could be certain kinds of fungi that are grown on agar plates. And agar is a polysaccharide that's actually derived from a variety of different kinds of macroalgae. We also have what are called alginates. Oh, the other use of agar that I should mention as well is that agar is actually used, and we use it a lot at IDT, because, for instance, one of the things that we do is we do agarose electrophoresis. So when we want to separate fragments, oligonucleotide fragments from DNA, we can actually do that electrophoretically. That is, passing an electric current across a gel that is actually derived from agarose, which is this particular type of sugar that is actually used to make agar. So that's another use for this. There are also things that are called alginates. There's something called alginic acid. Again, it's a polysaccharide with carboxylic acid functions. That's COOH functions on it. And this alginic acid, when it comes in contact with calcium ions, for instance, it will react and form a calcium alginate, which actually has a gel-like structure to it. So you can actually produce things that look like almost like gummy worms by taking the alginic acid and adding a little of the aqueous calcium salts to it. And I was going to demonstrate that to you because I actually have alginic acid, but because of the reorganization of my basement laboratory, right now I'm not able to actually find the little kit that I have that would enable me to do that. So maybe at a future point in time we'll do that. Carrageenans are another thing that are derived from algae, and these are used as stabilizers for dairy products. They're also used for people that just in general that want to eat they can't eat animal products. They can make a gelatin out of it, and I imagine, although I don't actually have a box of gelatin in the house right now, but any gelatin that would have that is kosher Some of it I understand is actually derived from fish, but they probably may use carrageenan from algae in some other of these kosher gelatins. So that would be a vegan or actually a kosher alternative to eating gelatin. The other uses that we have for algae are as a biofuel. So, for instance, we can get ethanol out of algae. We can get what's called biogas, which is actually methane, can be derived from algae. And interestingly enough, if you look at terrestrial plants, things like corn, for instance, we can get ethanol out of corn. You can actually get a much higher yield of ethanol from algae than you can from corn. So it may be that this in the future, the people will be looking at this more and more as a source for some of these biofuels. It's also used as a fertilizer, so the algae can be dried and ground up and just applied directly to the soil. It's very, very rich in a lot of compounds that are needed for plant growth. It's also a source of for people that are interested in these what they call nutraceuticals, which are actually the name is kind of derived from pharmaceutical. The problem with nutraceuticals is that these so-called nutritional products that you can buy at a health food store, they don't require, unlike pharmaceuticals, which the FDA controls, and they control the purity of these things, and they also are very, very careful about controlling what kinds of claims are made for a particular material. Nutraceuticals, that's not true. So anybody can take an extract of anything and stick it in a jar and sell it, probably if it's not poisonous. And in some cases it might even be poisonous. You don't really know. But a lot of this stuff that you buy as nutraceuticals really has no nutritional value, or it really doesn't do anything to promote human health. I mean, there's a lot of things that do as well, but it turns out that you can buy extracts of algae, and some of these things probably do something, but without actually having any mechanism of knowing just what the purity is or what the strength is, it's probably not an advisable thing to actually purchase. But algae themselves, if you're just going to eat the algae, they're good sources of things like iodine, calcium, and magnesium. And if you eat too much of these algae, it's also possible to be poisoned by taking in too much iodine. So you have to watch that as well. Algae can also be used, the macroalgae can be used, as well as the microalgae, can be used for pollution control. So people have done studies now where they take one of these macroalgae and they'll put it into a very, very large vat, and then they can pass carbon dioxide from an industrial process into these vats or these farms where they're actually growing this algae, and the algae will fix the carbon dioxide. That is, it will convert the carbon dioxide into polysaccharides, which can be utilized then. But the other thing is that you're actually taking CO2 from industrial processes. Let's say you have a coal-burning plant, and that plant is putting carbon dioxide out into the atmosphere. Instead of actually discharging it directly into the atmosphere, you could actually discharge it into these algal beds, and in that way you've reduced the amount of carbon dioxide that ultimately makes it into the atmosphere, and thereby lessening the greenhouse effect that we see from carbon dioxide. So that's another good use for algae. Other things that we can do, wastewater treatment is another thing, because algal compounds are also very, very good chelating agents. That is, that they will sequester and remove certain heavy metal ions. So where you have that in certain kinds of wastewaters, you could actually use algae to clean those waters up. Pigments can be derived from algae. Some of the purple or brown pigments that are actually found in algae could actually be extracted. And another thing that I didn't talk about yet is something that's called biochar. And this is a little bit different than the biomass or biofuel production. Instead of just taking the algae and burning it and using it directly as a fuel, which is it's possible to do that and derive heat from that. But what we can do is we can actually burn, rather than burning the algae, we can heat the algae up in an inert atmosphere. This is called pyrolysis. So if we do this maybe at 500 degrees Celsius, we can actually decompose the algae. We can break it down, and we get something that's left behind, a hard material that's called biochar. And the biochar has a number of interesting properties. It could be used as a filtering agent. There's a lot of things that you could do with it. You could burn it further and actually use it directly as a fuel. But what you get out in the biochar process, what you actually can extract from the algae, which wouldn't be possible if you just burnt the algae, are a number of industrially important chemical compounds. Solvents like toluene can be taken out of this, styrene, which is used to make plastics, perol is another nitrogen-containing heterocyclic compound that's industrially useful. Phenol, another compound. I'm just looking through this list here. Long-chain alkanes and long-chain alkenes are other types of materials that we can derive through the biochar process. And this is something that in the future, there's not a lot of this going on right now. It's more in the experimental stage. I have a paper here from the University of Leeds in England where they're actually they've designed a pilot plant to do this kind of thing. But you can actually get a lot of interesting kinds of compounds by doing this. So maybe somebody will do this on a larger industrial scale at some point in time. So that's another interesting application. The last thing I want to talk about here in terms of the usage of these materials that we can derive from macroalgae are the pharmaceutically or biologically active compounds that can be taken from macroalgae. And I have a few chemical structures that I want to show you. Now, these structures are actually, I don't expect you to memorize these chemical structures. That's not really what we're about. But I want to show them to you anyway because I want to show you the great diversity of chemical compounds that are being produced by algae. And a lot of these compounds are actually being produced by the algae as a form of chemical defense. See that there are a variety of things that we can get from the algae. We'll see that there are a lot of other drugs that come from marine invertebrates, and the algae are not, we don't tend to think about them so much as sources of drugs. But considering that there are something like 7,000 different varieties of algae, it's highly unlikely that very, very many of those have actually been investigated as sources for potentially useful biological compounds. So this might be something that we'll be hearing more about in the future.